Alright, today we are going to talk about section 4.1 from Algebra 2, graphing quadratic equations in standard form. So right now you need to be able to recognize a quadratic graph and know all the pieces necessary to graph it. So if you guys don't have graph paper in front of you, go on Schoology or go Google graph paper so you guys can have that, because you will want graph paper in order to graph these quadratics that we're going to be doing. Alright, so the first thing is the quadratic functions. What do they look like? Well, remember, quadratic functions are parabolas. They look like upside down or like straight up and down. Use smiley faces however you want to do it. When they're negative, they look upside down. And the way we write quadratics is ax squared plus bx plus c. Ax squared plus bx plus c. That's a quadratic function. Well, first thing let's talk about is, what does the parent function look like? The parent function is x squared. So y equals x squared. So let's look at this. Let's graph this using a table. So the points that I'm going to use for the table are -2, -1, 0, 1, 2. If I plug these in, -2 squared is a +4, because it's -2 times -2, -1 times -1 is 1, 0 times 0 is 0, 1 times 1 is 1, 2 times 2 is 4. Graph our points here, and we are going to get a parabola that looks something like this. Now forgive my artistic abilities. I'm not very good at drawing, but that's what our parabola looks like. Now the vertex, what the vertex is that's the point of symmetry. So that's that point right here. It's either our top or our bottom, depending on positive or negative. Our vertex for this point right now, or this graph, is 0, 0. Our axis of symmetry is the actual vertical line that cuts our parabola in half. You guys can see right there, that's going to be an x equals, because vertical lines, remember, are x equals, and it's at our y axis, so it's going to be 0, x equals 0. Our y-intercept, remember, that's where we cross the y axis, and again, you guys can see it's right there. Our y-intercept will always start with a 0 for the x value, remember, but at this point it's both 0, 0. Now we have to look, do we have a maximum or a minimum point? And what you have to think about is there a point where I can't go any lower than, or is there a point where I can't go any higher than? Well, you guys can see from this graph that we do have a minimum. We have our minimum point, and if you can't see, our minimum point is actually our vertex. It's right there where that red arrow is pointing at again. That's our minimum point. So that vertex, finding that vertex is pretty key. That tells you a lot of things. So the first thing we're going to talk about is how to graph with standard form. And we already did write this up there. Y equals ax squared plus bx plus c. That's your standard form. Now your bx or your c might be missing at some point because they equal 0, but that is what your standard form is going to look like. And we need to be able to tell all of these things from the standard form. So our axis of symmetry, the way we find our axis of symmetry is we are always going to plug in x equals the opposite of b over 2a. So whatever that is, we're going to plug it in. And I'll show you what that is in a second. It's going to get a little confusing here with what I'm putting up here, but I promise you I'm going to show you examples. Our y-intercept, remember, our y-intercept is always, our x always equals 0. Our y value is always going to equal that c value, our constant value there at the end, 0c. Now the notation that I put this in for the vertex might get a little bit confusing. But what we need to do for our vertex is our x value is going to be -b over 2a. And our y value, well, that's going to be when we plug in our -b over 2a, what does it equal? So this is function notation for f of -b over 2a. So what is y when I plug in that x value that I just found? Now if you guys look at our table, what you're going to want to do for your table is you're going to want to find 5 points to graph. But really it's going to be pretty easy. This middle number I'm going to find that I'm going to put in there is going to always be my vertex. This is always going to be my vertex right there. So you're always going to put your vertex in the middle. Now, depending on what you guys have for multiples, usually you're going to go up by 1, down by 1, up by 2, down by 2. But you need to go the same distance. And I'll show you what I mean by that in a second. But put your middle number as your vertex always. All right, let's do some graphing so you guys can actually see what this is about, what I mean, and all that good stuff. So here's my first equation, y equals x squared minus 2x minus 5. So the first thing is, let's find our axis of symmetry. Remember, to find your axis of symmetry, x equals -b over 2a. Well, we have our A is 1, our B is negative 2, and our C is negative 5. So really, x equals negative negative 2. So I'm going to put this in circles so to see that. Negative negative 2, so negative negative 2 over 2 times 1. Well, negative negative 2 is 2 over 2 is 2 is 1. So really, our axis of symmetry is x equals 1. Now the vertex, this is what I was talking about before that looked really confusing. But the vertex, first thing we're going to do is we're going to bring down our axis of symmetry is going to be our first piece. Now to figure out our actual vertex, our y value, we're going to take this equation, our original equation, and we're going to plug 1 in for it. So y is going to equal 1 squared minus 2 times 1 minus 5. We can see it's going to be 1 minus 2 is negative 1 minus 5 is negative 6. So you can see it looked a little confusing when I wrote it out, but it's really not that confusing. You just plug your x value into your equation. Our y-intercept, again, all we have to do is look at our c, so it's going to be 0, negative 5. Now we have a lot of information right here. We have a lot of information that I can go and graph, and I'm going to graph each piece real quick. First thing I'm going to do is at my axis of symmetry is I'm going to draw a dashed line there. So where x equals 1, I'm going to draw a dashed line, and wish I could draw a little bit straighter there. Let me try that again. Now the reason I'm doing that as a dashed line is because it doesn't actually belong on our parabola. That's not actually part of our parabola. But I put it there so I can see, because that's where axis of symmetry, that means everything is going to be flipped over that piece. So let me graph this first point, our vertex, 1, negative 6. So 1, 2, 3, 4, 5, 6. There's our first piece. Now I'm going to graph my y-intercept as 0, negative 5. It's going to be right there. Now what I mean by the axis of symmetry, everything being flipped, if I have this point right there, all I need to do is count over 1 from the axis of symmetry, and I know I have another piece. I know I have another point. Those two are going to be across from each other because with our parabolas, it's like folding it over that axis of symmetry. Now I need to go and I need to find some other points. So I don't have all the points I need, so I'm going to pull over my... Ooh, that didn't work out very well, now did it? I'm going to pull over my table here, and I'm actually going to put points in there. And again, remember, in my middle point, I'm going to put my vertex, 1, negative 6. We also already know 0, negative 5. And again, like I said, if I go down 1, I'm going to also go up 1, so it's going to be 2. And we already figured out that is negative 5 as well. So now I need to figure out really one more point, because if I go to negative 1 and 3, those two are going to be the same. They should be the same if I found my vertex correct. And the way I figure out what 1 is, or negative 1 is, I'm going to plug it into my equation. So y equals negative 1 squared minus 2 times negative 1 minus 5. So really I'm going to get 1 minus negative 2, so really plus 2, so it's 3, minus 5. Y is going to equal negative 3. So my two more points that I have are y equals, or negative 1, negative 3. So negative 1, 1, 2, 3. And I have negative, or positive 3, negative 3. And you can look, they're mirrored over that axis of symmetry. Now I just connect my dots, and that's my sketch of my parabola. Now you can look, does this have a maximum or a minimum? Well, it's opening up. That means it can go only so low, so this is going to have a maximum. And the maximum, again, is going to be my vertex. All right, let's try another example. That one might have been a little confusing. Let's try one more. So if I have f of x equals 2x squared minus 8x plus 6, let's graph that. So first thing we need to do is find our axis of symmetry. So we're going to have x equals negative b over 2a, so a, b, c. Negative b, so negative negative 8 over 2 times a, which is going to be 8 over 4, which is 2. Our axis of symmetry, x equals 2. All right, so to figure out our vertex, remember, we take that 2, that's our x value, and we plug it into our equation. So 2 times 2 squared minus 8 times 2 plus 6. You can plug that into our calculator, whatever you need to do. But you'll get 8 minus 16, which is negative 8, plus 6 is negative 2. So our vertex is at 2, negative 2. We also know our y-intercept is 0, 6 because of our last number there. So now again, I'm going to bring over my table and I'm going to graph, or I'm going to put in the pieces that I know. I'm putting my vertex in the middle, so I know it's 2, -2. Now 0, that's going to be 2 places away from my vertex, so I'm going to count down 1, 0. I know that's 6, so I'm going to go up 3, 4. Since I went up 2 more, that's going to also be 6. So now we need to find what 1 and 3 are actually going to be. So let's plug those into our actual equation, the original equation, for our x value. Y equals 2 times 1 squared minus 8 times 1 plus 6. Well, we'll really get 2 minus 1 is -6, plus 6 is going to be 0. So y is going to equal 0 for both of those pieces. Now let's graph them all. So let's graph each of these pieces. You can graph your axis of symmetry if you want to. I'm not going to choose to do that because I found all my pieces. So we know that we're going to graph 2, -2. There we go. We're going to graph 1, 0. There's that. There's that. 1, 2, 3, 4, 5, 6. Now we just connect our pieces. Now you can look, that one looks a little bit more stretched out than my other ones did. But first, before I go to talk about that, let's talk, does this have a minimum or a maximum? This has a minimum. Now, what I was just going to get to is let's look at the difference between these two graphs and our original parent graph. So on each of these, I'm going to graph the original parent graph quick. All right, so you guys can look at that first one. It got moved down and to the right a bit. And you can look at the second one. It looks like it got stretched out, and it also got moved to the right and down as well. So you can see what's happening on those parabolas. They're moving them around, stretching them, shrinking them. That number in front of that x squared, that a value, that's going to tell you if it opens up or opens down, because if it's a positive or a negative, negative is going to open down, positive is going to open up. Let's do an example of one of those real quick, and then I'll call it quits. So here's an example, and I already told you what's going to happen on this one, but I'm going to find each of the pieces. So first thing we need to do is find our x equals -b over 2a. So -4 over 2 times -2, which is really -4 over -4. So our x is going to equal 1. That's going to be our vertex. Our x value is going to be 1. Plug it into our actual equation, and we'll get our y value is 5. Our y-intercept is going to be 0, 3. And now we need to go and we need to plug in our points. So first thing I'm going to do is I'm going to graph each of these pieces. Because remember, in our axis of symmetry, we know that since we have 0, 3, we can also go over and we have 2, 3. So now when we go to our table, we can plug in our vertex as 1, 5. We have a point at 0, 3. We're also going to go down to -1. We know that 2 is also 3, and we can figure out what 3 is off finding out what -1 is. So what I'm going to do is I'm going to plug -1 up into my equation, and I get -3 for both of those. So -1, -3, and then we can mirror over again. Now we connect our parabola. You can see the reason that it's going opposite, why it's flipping over, is because of this negative symbol in front of the A. And because it's negative, because it's flipped over, we're going to have a maximum. And now I just realized that on that last page, I said that this had a maximum when I was totally wrong. This has a minimum. I apologize for that. Silly, silly Mr. Mohr. So if we look at this one, this has a maximum because it's flipped over and you can only get to a certain high point. It's like a hill or a valley. The hills, you can only get to a high point and those are negative. Nobody wants to run up a hill, right? The valleys, they have a low point and you're all fine with running down to the valley. That's real easy to run down. You can also look at it like a frowny face. When it's negative, usually when you're negative, you're frowning. So when you have a negative graph, when you have a negative in front of that x squared, you should be frowning. It should look like a frowny face. When you're happy, when there's a positive number in front of that x squared value, should be smiling, happy. All right, I'm not going to do any more examples for these. I feel like you guys can rewatch some of those. There are a lot more examples on your guys' sheets in here, or if you guys went and printed off the notes here, if you didn't print off the notes, here are some more examples. You guys should be able to graph these now, though. All right, let me know if you have any questions.